18.4. That's the approximate percentage of occurrences of ear-related injuries that unfortunately happen during cochlear implant surgeries. Combine it with the 700,000 plus registered device implants worldwide since the December of 2019, that's at least 129,000 cases of injuries occurring during the implanting process. And I know we can all agree, that's an unacceptable number for something that's intended to improve, not degrade. In some extreme cases, the procedure has caused patients to be disqualified from future ear surgeries entirely, as their current ear composition is now beyond repair. Me and my team wanted to make a change to this and drastically bring down this number ASAP. So we put our minds together with our supervisor, Dr. Ajay Mahajan, and his team of medical professionals and graduate students to create a practical training simulation that surgeons will be able to repeatedly train with to become more familiar with navigating the cochlear duct during the implanting process. And then me, myself, Devin, and Sydney definitely had our work cut out for us, as this was more of a medical device R&D type of project, as we were mostly in part of the researching different materials that we should test upon in order to best suit the membranes of the cochlear duct. So getting the conceptual design portion of it was definitely going to be a first for us, as in our engineering studies, getting that formulated was one of the first things we wanted to make sure we got done in order to get the brainstorming process off the ground, the conceptual design as far as the sketches and the different modeling for that was definitely a first for us, and definitely having to put our heads together as far as reaching past our own studies and our own knowledge in order to find out different types of polymers, materials that will best be suited for this process.
Because it takes only about 0.05 newtons to puncture through the membrane within the cochlea, it can be very difficult for the surgeon to sense the force on the electrode before puncturing. In previous methods, the only way of training surgeons for this type of surgery was through the use of cadavers. This is because it provided the most accurate experience in terms of forces and geometry. The downside of this method is if the student were to rupture the membrane, they have no way of knowing until after the cadaver has gone through an MRI scan. In addition to this, the cadaver can only be used a limited number of times for practice, and this means the student would have to obtain a new cadaver almost every other time.
After our team's information gathering and concept generation, we eventually settled on a design that would be able to train surgeons to have a feel for critical force levels. In order to achieve this, we decided to use a model that would implement disposable materials that rupture when the critical force has been reached. So during the training, surgeons would utilize this feedback in order to identify the force limits they should set for themselves when performing cochlear implant surgeries. Now here is our training model. It uses the same material clamping structure as our test setup to ensure that the results carry over. It also offers adjustment capabilities. This ensures that trainees can contact the disposable material at any insertion level during the implant process. The trainee interfaces with this model by inserting their electrode through a small window that is meant to simulate actual surgical conditions. They will identify critical forces through the feedback they receive by the rupture material. In order to test materials for this training device, we designed the measurement setup shown here. So this setup utilizes a jewelry scale as well as 3D printed components in order to obtain data on force values that cause the test materials to rupture.
One thing I believe that we've all got an idea of is the value of teamwork and the idea of having multiple minds come together to achieve a common goal and succeed at achieving that goal as well. Whether it's during the brainstorming process, the conceptual design, all things of that nature, we all came together in order to achieve this common goal and really put our minds together in trying to change the world one day at a time. Along with that, the use of resources was definitely a big thing that we had got more information and experience with. Dr. Mahajan providing us with the facility that we were able to test our procedures with, the medical professionals that supplied us the electrode implants that we use for the testing, the scale, all of that, just being able to use our resources actively and effectively in our work was a big thing for us.